Hi and welcome to this section where I would like to look at examples or further examples. I'd like to look at further examples on complex integration. Complex integration. Alright, so first we are going to state something here which is going to make our life easy. If we want to integrate, okay, our function f of z of our part c with respect to z, we are going to make a change of variables here, okay, and then we are simply now going to change, parameterize our function here. And because integrating over this part c may be a little complicated, since for complex numbers, the path here is in a plane, okay. So here we're just going to transform it something we are more familiar with, like integrating just along a straight line path. So we can say maybe it is the integral from t is equals to alpha up to t is equals to beta over our function f z, which is now a function of t, okay, which has been parameterized that way. And then rather than having that, we shall say dz times excuse me dz times dt, okay, which ideally we are going to write as the integral from t is equals to alpha up to t is equals to beta of f of z of t. Okay, this one here will give us z dash t and then dt. So we'll make it excuse me so we'll make this change of transformation, and then rather than integrate over that path, we shall now integrate over this straight line t. Okay, sorry. So let's look at the first example here. So okay, of course for these ones here, we know that z is equals to x plus iy. Therefore z of t will be equal to x, a function of t, plus y, that x parameterized by t, and then also y parameterized by t, okay, by the variable t, okay, that is the notation. So here the first example, let's see. So we want to evaluate this integral of a part c, okay, from 1 plus I, the complex number z1, 1 plus I, the complex number z2, which is 3 plus 3i, okay. This is the real part of z, and this is the imaginary part of z. So what is this? Of course we know the value here is 1 because I is 1, and then the value here is 3, that is 3i. The value here is 1, and then the value here is 3. Now you see that this is a straight line, okay. That part is represented by a straight line. Therefore we can try to write it down as the equation of a straight line. Y is equals to mx plus b. We'll use b since we have already used c to represent the path. So the gradient m, of course, the change in y over the change in x. So the change in y, we have 3 minus 1 over the change in x, 3 minus 1, and then you realize that that is 1. So y is equals to mx and then plus b. So for any point, whether you use this point to substitute into, for any point, whether you use this to substitute in for the value of y, which is 1, and the value of b, the value of x, which is 1, you will find that our value of b is 0. Therefore, we have that y equals to x. So usually we shall just let x, the independent variable, be equal to t. What we are using to parameterize. So we shall just let x be equal to t. That is our independent variable. X equals to t. And therefore, if x equals to t, then y is equals to x, implies that y is equals to t. And ideally here, what actually we are trying to say here is now x of t, equals to t, and also here now y of t equals to t. So that means that our z of t is given as, which is given as x of t plus, which is given as x of t plus I y of t would be equal to x of t is t, and then y of t is t as well, but we have I y of t, which is t. Then we know, we have said that then we have to compute dz. Yes, we have to compute dz. Let's see what we compute here. We have z dash of t. Let us just compute z dash of t, and then we shall just substitute in here with dt. So z dash of t, so z dash of t is simply going to be, now when we differentiate with respect to t, we have 1, and then with respect to t we have I. Therefore now we can write that our integral over that part c of our function here f of z, maybe one thing I forgot to say is that for our function we wanted to integrate this where our function f of z equals to z. For our function f of z equals to z. So that means that if we are integrating from that to that of dz, it is the same as integrating from t equals to, we say that since our independent variable is what we let it equal to t when we are parameterizing here, that means that t takes on the values of x. So t will start from 1 up to 3. So it is the same as saying the integral, just a minute, the integral from t equals to 1 up to 3 of f of z of t z dash t dt. So now we have from 1 to 3 f z dash of t. We know, we have already been given that f of z is z. So if f of z is z, what is f z of t? It is simply going to be z of t, just the identity. If it was maybe something else like f of z is given by z squared, then this one here would be z squared, and then we'll have to square everything in z of t. But now the function here is very simple. F of z is simply z. Therefore, f z of t is that. So we have this. So f of this here is simply giving us z of t, which z of t we already know. We have already written it here. This one here. Z of t is that, and it gave us this expression. So we have t plus it. So we have t plus it, and then z dash of t, this one here, which is 1 plus I, and then we have dt. So now the rest is, a piece of cake for you, I suppose. So the rest is just from 1 to 3 this and that, you have t, then this and that, you have it, then this and this, you have it, and then lastly it and I, you have I squared t. I squared is minus 1, so you have minus t, and then you have dt here. So we are integrating from integral from 1 to that. A few terms here cancel out, t and that cancel out, so we have 2it dt, which is going to simply be we have 2I, those are constants, we can pull those out, and then we have t squared over 2, and then where limits is from 1 to 3. So this is going to be 2I into the upper limit is 9 over 2, and then the lower limit is 1/2. So this is 4.5 minus that is 4, then 4 times 2 is going to be 8I. Okay, and this is ideally our integral of a c of f of z, which is z dz. Simply give us this. Okay, actually over this we can say from 1 plus I up to 1 plus I up to 3 plus I. 3 plus I, 3 plus 3I, 3 plus 3I. Yes, 3 plus 3I, 1 plus I. Alright, now let us consider another scenario. Let us consider the case if now we have a horizontal line. Boom. So as usual, imaginary part of z, the part of z, the origin. Now let us call this one here C1, and our C1 is given as the Z1 here, the first number here, complex number. We want to integrate from 1 plus I up to the other complex number here, which is 3 plus I. So we can see that the y is fixed at 1, I is fixed at 1, this is 1 as well, and this is 3. So as usual, now we are going to say that we can represent this as the equation of a straight line. Okay, so y, but do we need? I don't think we need, because y is already fixed. We already know the gradient of this line here is 0. Okay, and y is fixed. The value of y is constant at 1, so we just say that y is equals to 1. Okay, that will be our equation. So the equation of this line is simply y is equals to 1. And then we say that we let our x equals to t. Okay, so now integrating of our part C1 of f of z dz is going to be the integral over C1. F of z we say is z, it's cause we said f of z is z. Okay, so we can just write that. It's going to be equal to now the integral from t. Okay, now t is going to range from 1 up to 3. Okay, fz of t, of course we know here that z is equals to x plus iy, and then we know that z of t is going to be x of t plus iy of t, and then our that is going to be x of t is t from here, and then plus I, and then y of t, y is a constant, so I times 1, which is simply that. Okay, so we have that this one here at the back of our mind, we know it is going to be given by fz of t times z dash of t dt, which is going to be the integral from 1 to 3 fz of t. Okay, we know f of z is z, therefore fz of t is simply z of t, but what is z of t? We already have the expression of z of t, which is this one here. So this is t plus I times the derivative. So what derivative? If we differentiate, get the derivative of here. So differentiate here, we get 1, and then I is a constant, we get 0. So this, the whole of this is simply 1, and then dt. Okay? So which is pretty straightforward, which is going to be t squared over 2 plus it, and the limits are from 1 to 3. So here, upper limit, we have 9 over 2 plus 3i, then minus lower limit 1/2, then minus I. So that is 9 over 2 minus 1/2. 9 over 2 minus 1/2, that is 4, and then 3 minus 2i should give us plus. 3i minus 2i should give us 2i. So we have 4 plus 2i.